Yes?
Well, as I understand it, the services are still, the behavior of the services and the data is still independent of each other because they all plug in separately.
Mm-hmm.
But I'm not sure that's exactly workable because usually you do things like this person a discount if it's in a group, but this booking in the low season. It's very much the combination of data that you need in these kind of pricing engines.
So you're absolutely right that it's challenging to create rules or service decomposition in such a way that you don't end up having to cross the boundaries. That is the job, as I mentioned before, of BAs and architects working together with the business stakeholders to say, don't tell me how to write the rules, tell me what is the outcome that you want to achieve, and let me see how I can organize the data and the functionality and to preserve boundaries to achieve what it is that you want. Now, sometimes the challenge is the information that we're getting from the business is, well, I've created an Excel spreadsheet that does it all. So just take the Excel spreadsheet and put that into this thing, and then everything can touch everything else, right? So that's the problem when they're not really giving us requirements, but they're saying, use this solution, and then just implement that in code. So that's always the pushback. That's always the stress, where we need to say, all right, so let's take a couple, in essence, let's work out a number of test cases. So instead of doing test-driven development, we start writing the tests after the fact. And to say, the output of your model was X for this set of data, and Y and Z, and we might create 20 test cases, 50 test cases, something that we can get agreement from the business to say, if we can replicate the results of your model for these 50 test cases, can that be considered a true implementation of what you need? And it requires...
You're saying it may seem like you need to combine data from several services, but if you do the right analysis, it would not be, turn out not to be necessary.
Correct. So from what I've seen, and I've seen a bunch of domains, every single time I've been able to say, okay, so if we pulled it apart this way and we did this kind of transformation that could be run in any order, that would achieve the same end result as what their original implementation did. So I have no mathematical proof that it will always be possible to do that, but from my experience, I've been able to achieve it enough times that I am fairly confident that it's worth trying, that the boundaries are valuable enough to fight for, as opposed to saying, well, no, whatever's in here can access anything anywhere. And the problem then becomes, once you have that, let's call it black hole of coupling, where any logic can operate on any data, it's really hard to preserve boundaries anywhere else. So I'd say here it's the most challenging, therefore we need to be the most disciplined. All right? But in my experience, it's possible. It is possible. The best way of achieving that is to sit down with the stakeholder and to say, let's work through test cases. I say, there are too many. Anytime somebody says there are too many, that usually means 20 or 30. Okay? Not hundreds. But even if there were hundreds, it is something that can be decomposed. All right? Yes, Martin.
So is there a way to do this if you can't manage to find these good solutions? Say you have risk calculations that are sort of statistic formulas, and I'm not sure you even can decompose them because the sum of this squared and then it's really complex.
Right.
And they take all these numbers and put them in different places, and then you get another number.
Right.
it was possible. So what
Well, I'm not sure I'd agree with the statement that people would have decomposed it if it was possible. People are lazy.
I think that at least they're sort of the essence of the different parts already. In a way, they have sort of already scrapped all the unimportant parts. So, is there a way to sort of maybe use two engines or
Okay.
introduce this dependency of one part that actually depending on the result of another in some way?
Right. So your question of can we do this with two engines? Two engines in essence is one engine with two parts to it. All right. So it's not an increasing number of engines is just the same thing as one engine. Let's start with that. Okay. The other part of your question, when you talk about having a statistical model, what you do with a statistical model is, in essence, what you build up is a data set of outputs back in time. So the statistical model told us that the value of risk was X for October and Y for September. And in essence, that gives you a set of test cases to say the statistical model created this set of outputs for that set of inputs over time. If we can create an engine that is more boundary conscious, that recreates, it doesn't even need to be precise. Right? It doesn't have to give the exact same risk score. If it's off by, let's say, 5%, then the business said, that's fine. If you said, it's 70% risk or 72% risk or 68% risk, for me, that they're all the same thing. So it gives you the ability to reverse engineer tests from history in a way that the business doesn't actually need to give it to you. And then you use that as your input for the new model and the boundaries that you're trying to create. That's number one. Number two, the thing about statistics is that oftentimes, and I understand now why you're asking the part of in essence, creating a second engine, we oftentimes use the result of the previous calculation to feed into the next one. So in essence, it kind of loops back into itself. But that's fine. That doesn't break apart the boundaries. It's saying take the output of the engine from last month and use that as a part of the input for the calculation this month. All right? So in my experience, that doesn't break the boundary at all.
I think I was more thinking of that you make a certain calculation and then you take that result and put it into a different calculation.
Mm-hmm.
So in that case, if the green service part of this, it needs to know which calculation it's supposed to do when it gets the data, because it depends on if it's already done part A, then it needs to do part 2, but the blue one needs to do something in between. So the order sort of
Right. So there are variations on this theme. For example, that you have a certain, it's called algorithm that most things are going through, a calculation, where green takes part in this part of this step of the calculation, and this part of this step of the calculation, and that part of that step of the calculation. And red is responsible for this other part of the first step of the calculation, this part over here, and that part over there. And what happens in these places is all based on the same data, but it's different parts of the algorithm. It's different parts of the calculation that each one of them owns. So there's often that type of composition that happens in the engine as well, that you have a certain function, algorithm, flow, whatever, that you wouldn't necessarily say that green owns that calculation, but that green and red and blue take part in that part of the calculation. And then the output of that feeds into the next step where some other calculation is done that other services might be composed into. Now again, I'd need to see the specifics of a calculation to see how it can be broken apart. But I need to be honest here. Most of the statistical models that businesses are using, somebody made them up. You need to understand, it was a process of trial and error that they said, what if we increase this to 1.05? And what if instead of doing the square root, we did the 2.05 root of a thing? And they're just constantly tweaking and smacking and adjusting this thing and rerunning that against all of history and then saying, ooh, that actually fits the data better. That if that was the model that we had, it would have been a better predictor of the past. Those aren't requirements. It's just a trial and error thing that said, oh, okay, this seems like it fits the data well. All right? So understanding that the source of it is made up and that it's not a true requirement, it's a model, that if we can create another model that is equally predictive, then that is viable for the business as well. And that often requires input from multiple business domains and data science statistics type people working together off of large data sets of the past and creating multiple models for the future. Okay? Hold on a second. Was there another question in the back? Yes.
So if you have one of these engines, say like a fraud engine, as part of your order processing flow, for it to actually get triggered, is it okay to listen to an event, or how is that engine triggered to actually produce a work?
So the question is, how would an engine like this, let's kind of create a box around this thing, how does this get composed into the other flows that are happening in the system? So you said, is it triggered as a result of an event? Now, the answer is sometimes. The question is, who is raising the event? So it could be that sales is raising an event saying order accepted, and then that triggers this. Or it could be that this fraud engine is actually involved also in the checkout process. So for example, somebody goes in, sets an address, and doesn't complete, and goes back and changes the address again, and goes back and changes the address again. So fraud may be plugged into some of the things that are happening in the checkout process. So the thing that might own the addresses might say, if the address for a given checkout was changed more than n times, then do something. Kind of invoke the fraud engine to start to kind of trigger these other things to get into the pay attention mode. So the event might not be a regular service level event like order accepted. It could have been much more detailed within a given service, the part of the service that is part of the fraud engine, but most importantly is connected to the rest of the green service. So it noticed that, oh, okay, I see you added something to your cart and then you removed it. And then you added 5 of them and then you removed them. And you did that. So that already increases the fraud score of this checkout by 20%. So a lot of times, especially when we're talking about fraud, it's those little things that are happening that each service can notice that will feed into it that causes the engine to hum a little bit louder, rather than being an explicit, oh, A happened, now we need to go do this. And that's why it's valuable to have this type of plug-in model for the engine. Does that make sense? Okay. Yes?
I was thinking about, couldn't you make sort of service which in its own right is a service for fraud detection?
Okay.
Something like that. That is cross-boundary, but that is listening to events and have patterns that says, yeah, okay, this matches a pattern. This will be processed while I read here. Then you start the process about gathering the information.
Right.
Instead of, every information needs to be gathered every time. And then you start to crunch the numbers, because
right.
it's always one of the triggers in the system which actually starts the process. Oh, this amount is bigger than that. Oh, you ordered 1,000 books instead of 1. Or
right.
Shipping address change. Yeah, some trigger. And then the process, okay, stop now. I need to, every service now. Now I need to go in and check everything, and then I can, everything looks okay. And then
But it's in its own right something that usually someone needs to look at or something. It's okay to start and gather the information there and then keep
Right.
going.
So the idea of having a fraud service or a risk service or a pricing service that takes full control over all of this and, as you described, listens to events from other services will often require those services to publish events that they otherwise would not have published, right?
Yeah.
So if at that point in time we'd say, well, the shipping service that owned the shipping address up until that point had no need to expose to anybody else when a customer adds or changes a shipping address for a given order. Now all of a sudden it needs to start exposing that, right? So that the fraud service can know, okay, something here is happening. That's our problem with setting up a service like fraud as a service in its own right, because it ultimately requires all of the other services to expose everything that's happening in them, and that creates a large amount of conceptual coupling. And as you were saying correctly, fraud needs to have the ability to intervene in almost any service's business flow. That hurts their autonomy quite a bit. So it's really hard to say that those services will remain technical authorities of their business capability when there is something like fraud that is that involved in anything and everything that they're doing, right? It's also hard for us to say that fraud is a technical authority of a business capability because it can't do anything if those other services are not playing along enough, right? So there's a special relationship there that can't really be resolved with fraud as a service. Now, again, part of the issue is that because the term service represents a significant high-level architectural thing, people, developers and business that have spent a great deal of time in a fraud domain or in a pricing domain feel that it's not right, that the thing that they spend all their time on is not as architecturally significant as other things in the domain are. So it's kind of this emotional, psychological, political thing to say, of course fraud is a service. It's just as important as sales, billing, shipping, if not more so. But the justification that's being used is not a technical justification, it's a political justification. It's, this is important to the business, ergo it needs to get its own service, rather than saying, this is important to the business, this is the right pattern with which to implement that important thing, while balancing all of the other needs. Right? So that's the challenge, to say, well, we're doing service-oriented architecture. Well, isn't fraud a business capability? And the answer is, well, kind of, but it is too intermingled with other things to follow the same boundary constraints as they do. Therefore, we need a different model. And this is true of fraud, risk, compliance, pricing in certain domains. There's a whole bunch of them that we end up using patterns like this for, right? Now, the issue is if you don't follow a pattern like this, then you end up with sort of a black hole that the rules in here, which are often fairly complex, can touch all of the data. And then you lose all boundaries and everything kind of becomes request response, REST services, calling other REST services, a great deal of coupling, and then along the way, performance problems as well. It's too hard to separate things out afterwards once you've created the central fraud service.
Yeah, but it's essentially the same thing as when ITOps does an integration.
Correct. So I'd say that this is even more risky than the ITOps integration scenario, because when we're talking about an integration, it's more of a technical transform to say, you know, their addresses have the house number as a separate argument, and we have that as part of the same string, it's more simple transformations. Here it tends to be much more complex calculations and more dependencies between things, right? Chris?
Does the owner of the answer depend on who triggered running of the engine first?
So let's say the output of the pricing engine was $72.48. Is the person that owns that the same person that owns the list price?
Well, I was thinking
Is that
in the fraud case, let's say, I think
okay?
it's an easier example. It could be triggered by the green service if the green service detects exceptional number of delivery address changes. It could be detected by, it could be triggered by ops. If ops detects it's coming from a blacklisted IP.
Mm-hmm.
It could be detected by someone else if the,
Right.
if the size of the basket is over 10,000 euros.
Right.
So there's lots of different activities, perhaps, or triggers
Right.
to start the process.
Right. So I wouldn't say that the thing that triggered it is the thing that owns what comes out at the other end. The what comes out at the other end ultimately needs to be interpreted, and part of that is at the fraud engine to say, okay, the end value was X. What does that mean that we're supposed to do? And part of that might mean, divert that to be handled by a person, or throw up an additional challenge in the process to say, oh, this is a different IP address, we're going to trigger the two-factor authentication type thing. So the what happens as a result of the score is also part of the engine, all right? So you're saying, who owns the end result? It's not so much the end result, it's that what we do about the end result is also the responsibility of that engine. And then that could be, what do we do here? We trigger red, even though it started with green. Okay? Then red does this, and then based on that, that feeds back into the engine, results in a lower score, a lower risk component, and say, okay, so we'll accept that. For the most part, the final bit of the who owns, it's more that the fraud engine is recording, it has an audit to say, this is what happened, we recorded the fraud score was X, this was the action that we took, then this happened, that influenced the fraud score, brought it down to this, we allowed that to go ahead. Usually, there is not very much business decisions done in the online transaction processing of what was the fraud score that was calculated for a certain thing last week. It's interesting from a data science perspective of analyzing how well are we doing things here, but it doesn't really go out to other business domains, right? And that's different from example, let's say price, where at the end of this we say, well, the price is $72.50. That $72.50 needs to be charged to cards and it needs to appear on invoices. So in those cases, there actually is a larger need to say something needs to own this because it becomes business data, where the fraud score really doesn't. Okay? Yes?
So I've been trying, it looks like a pipeline, pipes and filters, and that's, but now what you're saying is this is more a program that uses different components from different services, and it's not like data is flowing through and pops out at the other end. It could be that no data is coming out, it's just another process starts.
Right. So the answer is yes, it can be both. In the sense that if the nature of the logic has a certain pipeline-y nature to it, then having different services plug into the pipeline and some end result comes out at the other end makes a lot of sense. Pricing tends to fit that quite a lot. Okay? When we get into risk or fraud, then there sometimes is pipeline-y behavior, but it's less important what comes out at the other end, because that ultimately is So if the value that we got at this stage was greater than X, trigger green. If the value was less than Y, trigger red. And then, in essence, that's the end, as you described it, of the program. All right? But there often is some, we're doing this here and then that there. Different domains end up implementing things slightly differently based on the nature of the calculation, the nature of the services. So usually you'll tend to see, even in advance of finding services, that there's already some fraud, pricing, whatever functionality already built, and you'll be able to look at that and say, okay, I can see how that could be a pipeline. Or no, that doesn't really fit as a pipeline as much, but I can see a combination of components that are raising events to each other as in-memory events. Most of the collaboration happening between these components is in memory, all right? But it depends very much on what the algorithm is currently doing, okay? Yes?
Have you ever seen this implemented as an service plus Q? Literally something pops in,
Mm-hmm.
the engine pulls it up, has a look at it, transforms it, gives it a score,
Mm-hmm.
and then passes it on to the next queue in the line.
All right. So have I seen this as being distributed in the sense that phase one of the pipeline is some message handlers, and then that might publish an event which goes to another step, and then have I seen that? I don't think I've seen it. I'm not sure that I'd recommend it.
Parallel processing then, because they're all doing their own things.
Hmm.
You haven't got that one message which is being transformed, then transformed, then transformed. You've got several things,
Mm-hmm.
each of them doing their own thing at the same time.
Right. Most of the examples that I've seen of applying this approach tends to have, let's say, some similarity to what it's like to program in an end-service bus type of way, meaning that the engine exposes certain interfaces. You implement this interface, you are passed a certain message or data object that you operate on that. You use APIs of the engine to raise up other events that other things could be invoked by. But the pipeline tends to be much more in memory. The queuing and the transactional durability part are usually much less interesting. It's more we got triggered and we kind of go all the way through to the end, and then we do something. So even though there are multiple steps, there really isn't the need for transactional failover and retries between stages. So I'd say a lot of the in-service bus infrastructure benefits are less significant to building these types of engines. But again, I'd say that from a coding perspective, there are a lot of similarities to I'm plugging in via implementing some interface. So initialization logic for caching a bunch of stuff in memory like reference data, and then handling logic for when a given piece of stuff goes down the pipeline, the ability to raise events, but most of that is still in memory. So I wouldn't say end-service bus as a specific implementation, but a lot of similarity in the design patterns, right? Yes?
I'm still not sure I understand exactly in practice how this works.
Mhm.
At the end there where you either do red or green, is that a decision that green makes? Do I do anything and red makes another decision? Or does the engine actually own sort of its own part of the logic?
So this sort of final step behavior is
Any step in it. Is the engine logic in itself?
there
Or
often
just the sort of combination of all the different services?
there often is some logic in the engine itself, and that's the challenge. Is it's balancing what is the more, let's call it, technocratic logic versus what parts should really be carved off and be identified as being a stronger affiliation to the rest of the service. So what is purely algorithmic versus what is more data business oriented. And there's no clear cut, it's always like this or it's always like that. You really need to go through it, and it's always helpful to have let's call it the test matrix of, well, what value were we supposed to end up with to be able to verify that what we've done is true to what the business needs? Because there are so many cases to this that not only historically have we dealt with, but that will happen in the future, that we want to make sure that when we make a change to something in the engine, that we don't break or change the types of scenarios that we would have handled before. So is there something in the engine itself? Absolutely. It's not just a generic and service bus pipeline. This is a fraud pipeline. This is a risk pipeline. This is a pricing pipeline. So there's awareness of the data that we're moving around. Okay? Yes, last question.
So then, coming back to that point, or expanding on that point, then the code that is the pipeline, that also contains the more technocratic logic that's owned by IT ops.
So that's really the challenge, because there is I'd say it's the data science-y part of IT ops that is involved there. So that level of expertise is what is needed there. It's hard to say that is itops.fraud or itops.pricing. It's the group of people that are often data science statisticians, people that are very numerical, that are working alongside this group. So ITOps owns let's call it the engine framework, but that is, you can think of it as a separate part, just like the integration part is separate from, let's say, the user login, log out, change password. So that's one part of ITOps. This is another part of ITOps. Now, the challenge here in saying, well, who owns it? It gets back to what, from a team perspective or from where we put the code perspective? And that's the challenge, because this group really needs to work fairly closely with each other, but each of those members needs to be a strong liaison for, well, what else is happening in that service domain? So this is so your question of how do we handle this, who owns it? You could say both or neither, or this special group that we call the fraud group.
Maybe who owns it was two person. Where does the code live?
So I'd say that the code of the engine is part of the ITOps service, but we'd probably put it in a separate area. In other words, it doesn't have to be beside the login, log out, stuff. It doesn't need to be beside the integration stuff. It's its own section. So when we say it's owned by ITOps, you could make the point to say that it is the fraud subset of ITOps. It's its own source control repository. All right? Yes?
About the ITOps thing. So you said the fraud service, if we would have such a thing, it would be doing a lot of request response, and that would basically mean that it's not like a service on its own. But in this sense, ITOps will be doing the exact same thing, wouldn't it? It would basically follow all the other services for the data it needs anyway. What sense is that different?
Right.
From having fraud service?
Right. So let's be clear. The difference here is the engine pattern, right? The engine here is providing hooks into which various services plug in. It's not saying I need this data because I own the rule. The whole idea is that the business-specific rules are owned by the services. All right? So ITOps is building the fraud engine that has necessary components of modeling how fraud gets calculated, but not necessarily including the actual rules of, you've changed the address 3 times, that is significant, all right? Whereas in a fraud service, that rule of the number of times you've changed the address would be owned by the fraud service, right? And then that is where it ends up being overly familiar with the things that are outside of the fraud service, right? That's the distinction and why we talk about it as an engine. It's more of a callback type model rather than a request response type model. Okay? You could call it an implementation of the strategy pattern to some extent. Although the Gang of 4 strategy pattern is a little bit too limited in scope to cover all the needs of this engine, you might say that you have a number of strategy patterns that are applying at different parts of the engine.
The strategies might be.
Right.
It's a template pattern, right?
I'm not sure I'm familiar. I mean, there's a number of patterns that have the word template in them. I'm not sure.
Gang of 4 template pattern.
Okay.
So you provide the interface and someone else provides the implementation.
I'm not sure that that's my understanding of the template pattern. But in essence, it's saying that there is a plug-in type model. That yes, the engine defines interfaces, and those interfaces are meant to reflect different parts, phases, stages, whatever, of the fraud algorithm in this case. And the various services provide implementations for their part of that. But it usually requires, this is not like well, we're going to publish a NuGet package, and then other people will just figure out how to implement it. It requires a fairly deep, we're going to be sitting together for the next week, working through a bunch of these scenarios. You implement it this way, I implement it that way. Let's see if that works. No, that didn't work. Let's change the interfaces and try something else. Right? So it takes a bunch of time to get to the point that all of the pieces and all of the extension points and the data models that are flowing through them are actually defined. This is not something that somebody from IT ops kind of envisions themselves, builds a bunch of interfaces, says, great, I'm done, now the rest of you come in. Right? It's a joint group effort on that. All right, that's engines, and I think that's the last of the list of the questions from before lunch and from the past couple of days that I owe you.